when I say factors affecting nucleophilic substitution reaction, basic we have 3 to 4 factors. So we'll see all of them. The first factor would be the substrate. The second factor would be nucleophiles. The third factor is the leaving group.
Yes, sir.
And the fourth factor would be the solvent. So we'll see what are all the various factors that are going to affect, and the major factors I have mentioned. Shall we move?
Yes. Yes, sir.
Yeah. So first we'll go for the substrates. So what do you mean by the term substrate? I'm talking about the alkyl halide, because the alkyl halide is what the substrate it's what acting as a substrate in this reaction. So what type of alkyl halides can react? For example, first we have to know what are all the types of alkyl halides we have, and then only we will be able to say how they react. For example, when you take alkyl halides, there are totally, especially in the open chain compound I'm talking about, so you will find totally 3 types of alkyl halides. So the halogen attached carbon is called as alpha carbon. And then to the carbon, what is attached is what matters. If all of them are hydrogen, we call it as the methyl halide. If only 2 of them are attached, it is called as primary halide. Only one hydrogen is attached, it's secondary. If there is no hydrogen, and it is tertiary. So the remaining are alkyl group, carbon.
Yes, sir.
So now the question is, we have primary, secondary, tertiary. So methyl is a separate class. So methyl halide. Now the question is, which one will be more reactive towards the substitution nucleophilic reaction? It's a very clear point that I already told you, that in a substitution nucleophilic unimolecular, the reactivity will be from a methyl to tertiary. So from here to here, SN1 increases, while in the backward, SN2 increases. So it's very clear why SN1 increases, because a stable carbocation should be formed. So when I say stable carbocation, who can form a stable carbocation? A tertiary. Hence I said tertiary carbocations will undergo SN1 reaction, SN2 reaction. So which one is, what is the major requirement? A rear side attack. When I say a rear side attack, it should be having a less beta crowding.
Oh, okay.
So who has a less beta crowding among all? A methyl. Not even a primary, methyl. So that is why when you write the reactivity, it increases from tertiary to primary or methyl for SN2. From methyl to tertiary, the stability, reactivity increases towards tertiary. And again, white carbocation of tertiary is more stable, we all know, because I explained it last class itself. More the beta crowding, better the electron releasing group, or the plus I effect is quite high. So automatically the carbocation stability is high. So as you move from tertiary to secondary to primary and methyl, the stability of the cation is not much appreciable because of the less hyperconjugation and inductive effect. So this is the basic idea. Inductive effect and hyperconjugation, both are important aspects. Okay. So automatically you will find more hyperconjugation and more inductive effect in tertiary. Thereby the stability of the carbocation is quite high. Right? So this is about the
Yeah.
substrate. Now, what are the other substrates that we have? For example, let us take vinyl halide. So vinyl halide will not undergo any reaction. I mean, in the sense, will not undergo substitution, nucleophilic reaction at all. What is the meaning when I say at all?
So there will be no stable carbocation formed, and
Very good. That means you are trying to explain using SN1 mechanism. So an SN1 requires a carbocation. So vinyl carbocation is never formed, isn't it?
Yes, sir.
Why vinyl carbocation is never formed? Because this carbon is also electronegative. How the electronegative atom will give away the electron. So vinyl carbocation is not known. Vinyl carbocation is not known because of simple reason. This is sp2 carbon. So sp2 carbon is not so electronegative. Number 2 is SN2 mechanism. When I say SN2 mechanism, what do you understand from this? Rear side
Yes,
attack
sir.
is not possible here. Why rear side attack not possible?
Sir, just one minute, sir.
That means the pi cloud is here, right?
Yes, sir.
So if you try to attack a nucleophile from the rear side, what will happen? The pi cloud repels the attacking nucleophile. Thereby, no SN2 reaction as well. So both SN1 and SN2 are not possible in vinyl chloride because of one simple reason. SN1 is not possible because carbocation formation is not known. Why it
Sir,
is
why
not
does it
known?
repel, sir?
Sorry?
Sir, why is it repelling,
Very good
sir?
question.
when
Very good
nucleophile-
question. What is pi cloud? Electrons. What does a nucleophile have? Electron. Won't electron repel each other?
Yes, sir.
That's the concept. So a nucleophile
Okay.
carrying an electron comes and attacks with the electron, while the pi cloud is also made up of electrons. So the electron and electron repel each other. Thereby no SN2. Carbocation formation is not known because sp2 carbon is electron negative. It cannot give away the electron easily.
Yes, sir.
So that is how it works. Okay, for vinyl carbocation. Vinyl chlorides.
Yes, sir.
Yeah. Now let us go for another substrate.
Sir, 1 minute, sir. I'm copying, sir.
Copy me.
Yes, sir. Almost done. Yes, sir. Finish it.
Similarly, we have two more substrates which are well known for their reaction towards substitution, nucleophilic reaction. Number one would be the allyl halide. Another one would be the benzyl halide.
Yes, sir.
So in allyl halide, what will happen? So first the halogen will go out. So thereby you get a allyl carbocation. Remember, this allyl carbocation is stabilized by resonance.
Yes, sir.
So what will happen as it gets stabilized? Immediately, if there is an availability of a nucleophile to come and attack, it will immediately attack and form a product. Because the carbocation is stabilized by resonance. Similarly, this is allyl. Please make a note. This is allyl halide. This is benzyl halide. And you can very clearly see that in both the case, the alpha carbon is a sp3 carbon.
Yes, sir.
attached to an sp2 carbon. So if the sp3 carbon is attached to an open chain sp2 carbon, we call allyl. If the sp3 carbon attached to a benzene carbon, which is also an sp2 carbon, then we call it as benzyl. So again, what will happen in this case? The X minus will be liberated. So you will have a benzyl carbocation. What do you call this?
Benzyl carbocation.
So this will again get stabilized by resonance. It goes on. Now what is the next step? Take the benzyl carbocation, which will get attacked by the nucleophile, and your product is a nucleophile with the benzyl halide. I mean, in place of the halide attached to a benzyl group. So in both the cases, the reaction is possible. Allyl halide and benzyl halide, the reaction is possible. The nucleophilic attack is possible because they both form a stable carbocation. Why the carbocation is stable in both the cases? Because they are getting stabilized by resonance.
Yes, sir.
Copy?
No, sir. 1 minute.
Take it time, no problem.
Yes, sir. Done, sir.
Super. Now we can also see some more substrates. For example, have you heard about this example? Neopentyl bromide.
Yes, sir.
What is the IUPAC name of this compound?
Uh, 2,2 dimethyl.
1-bromo 2,2 dimethyl propane. Correct answer. So now what will happen? This particular this particular molecule is sluggish. What do you mean by sluggish? Very lazy to react, and the reaction is very slow. It will undergo substitution reaction, but the reaction is very slow. It undergoes very slow SN1 reaction. So for example, you take this bromide. What is the first step for SN1? Formation of carbocation. So this is a primary carbocation, correct? So a primary carbocation is always unstable. So what will happen? The methyl from here will get shifted. This is called as 1,2 methyl shift. Now what happens to the carbocation? It becomes a tertiary carbocation, which is stable.
Sir, but this shifting is very slow now, sir, as you said.
That's why. That's what I'm saying. The shift is very, very slow because of the bulkiness of the molecule.
Okay.
So the shift is very slow. That's why I said the reaction is very slow. Yet it happens.
Yes, sir.
The question is, though it is slow, it happens. Why? The happening is due to the stability of the tertiary carbocation. Okay. So now you add a nucleophile. It will attack the carbocation. So thereby you get a compound like this. See, other than this, we have various other substrates also.
Yes, sir.
You can also take isobutyl bromide.
Yes, sir.
So you take isobutyl bromide. In this case, it's a primary alkyl halide. Please make a note. It's a primary alkyl halide, correct?
Yes, sir.
Because it has only one beta carbon, other two are hydrogens. So very clearly you can see it's a primary alkyl halide. Isobutyl bromide. So now we all expect it to undergo what reaction? When I say primary alkyl halide, what reaction it undergoes? Yeah, when a primary alkyl halide will undergo what reaction? What is expected?
Sir, SN2, sir.
But it will undergo SN1 mechanism.
How, sir?
Let's see how. So now you take the same alkyl halide, that is alkyl bromide. What is the step number 1? For an SN1 reaction, formation of carbocation. Very good. So what will happen? A carbocation is formed, which is a primary carbocation, correct? At the same time, you can also see there is an hydrogen over here. So this hydrogen will get shifted here. We call this as 1,2 hydride shift. So what will happen? Automatically the hydrogen gets shifted to the terminal carbon. You get a tertiary carbocation.
Oh.
Tertiary carbocation is stable because of resonance and other things that you already know. So now you treat it with a nucleophile. So he will come and attack to the positive side. So thereby you get a product like this. So purely hydride shift and methyl shift can do any possible product. So SN1 and SN2 reaction depends on the type of the substrate and the stability of the carbocation they form. Is that fine?
Okay. Yes, sir. Yes.
Finished, Amma?
Sir, 1 minute, sir.
Yeah.
Sir, yes, sir. Sir, the screen is black, sir.
1 second now.
Okay, sir.
So now I would like to give you a question. So, shall I?
Yes, sir.
So because when you, whatever you learn, no, only if you solve a problem, you will understand it better. Write down. 2-bromo, 2-methylbutane reacts with aqueous NaOH to form dash. 2-bromo, butane.
Yes, sir.
Reacts with aqueous NaOH to form dash.
Yes.
Similarly, 3-chloro,
Yes, sir.
3-chloro, 2,2 dimethylbutane,
Yes, sir.
treated with aqueous KOH forms dash. So can you do this as a homework later?
Okay, sir.
So that is all about substrate ma. So nothing more than this. And very important, please make a note, alkyl chlorides, that is, aromatic chlorides, when you take chlorobenzene, they will never undergo nucleophilic substitution reaction. Please make a note.
Sir, can you repeat the point, sir?
Now the board is visible.
Sir, can you repeat the point, sir?
I am writing. Board le eidi podra.
Okay.
Chlorobenzene doesn't undergo nucleophilic substitution reaction So how do you substantiate your answer? Number one, it will not undergo SN1. Why? Because when you remove the chlorine from the phenyl ring, what will happen? It will form something called phenyl carbocation. Correct?
Yes, sir. Yes, sir.
Phenyl carbocation is never known. You cannot create a positive charge in an electronegative atom, right? Because here the carbon is again sp2 carbon. So it's very difficult to form phenyl carbocation. Number two, SN2 reaction never possible. Why? So when you take a benzene ring, how is the pi clouds projected? If this is your chlorine atom, how are the pi clouds projected?
Yes, sir, I guess.
So there is no rear side attack as possible at all. Even the nucleophile comes and tries to attack from the rear side, it is never possible because the pi clouds of the aromatic halide repels the incoming nucleophile. Correct?
Yes, sir.
Now let us go for the third one. What is the other option? There are two more reasons to be written here. So when you compare a chlorobenzene and you compare it to the cyclohexyl chloride, this is an sp2 carbon, this is an sp3 carbon. So it's very clear, sp2 carbon is more electronegative than sp3 due to, what is the reason? Due to increased S character. Whenever S character increases, electronegativity will increase. So compared to sp3, sp2 is has more S character. So being more electronegative, another electronegative group cannot come and attack. That's the logic.
Yes, sir.
Is there any other point left out?
I don't think so, sir.
Sure?
Yes, sir.
There is one more point. I want you to make a note of it, and that is the primary point I didn't give in the starting of the session. So when you take the chlorobenzene, it has 3 lone pairs. So one of the lone pair will come inside the benzene ring and thereby it leads to a resonance.
Resonance.
Correct?
Correct, sir.
So again it enters the benzene ring and it goes on. And can you see a double bond here? So we call this as partial double bond character. What is it called? Partial double bond character. Why this partial double bond character has come into picture? Due to
stabilize the
resonance. அப்போ partial double bond character இருக்கனால it's very difficult to break the CCl bond. Partial, I mean it has more S character இருக்கறனால you cannot break
Sir,
the
it's only partial double bond, sir. So you can actually break it three.
ஆனா டபுள் பாண்ட்னு ஒன்று வந்தாலே உன்னால் உடைக்க முடியாதுல்ல, பிகாஸ் கம்பேர்ட் டு சிங்கிள் பாண்ட் டபுள் பாண்ட் வர முடியாதுல்ல. அண்ட் தட் இஸ் நாட் த ஒன்லி criteria. There are other 3 reasons are there, no? SN1 is not possible because of phenyl carbocation formation is never known. SN2 is never possible because the rear side attack is repelled by the pi clouds of the aromatic halide. sp2 carbon is more electronegative than sp3, so breaking that bond is very difficult. And moreover, there is a partial double bond character as a result of resonance. Among all the factors, resonance is a more stabilized factor, isn't it?
Yes, sir.
So thus you can come to a conclusion very clearly that due to these 4 reasons, chlorobenzene can never undergo nucleophilic substitution reaction. So now you got the set of substrates. How many substrates you have got altogether?
One, two. 6 or 7, sir.
If you take a primary, secondary, tertiary, 4 தனியா எடுத்தோம். And then we saw neopentyl and then isobutyl and then we went for allyl, vinyl, now chlorobenzene. Correct?
Vinyl.
So totally we have 9
Yes, sir.
9 things I have given. Idillada I have given you 2 examples. So 11 examples you have in your hand. Either maybe they will not ask anything in CBSE. This itself more than exhaustively I have given. Okay?
Sir, can you say the last points?
Yeah. Take your time. No problem.
Yes, sir, complete.
Super. Now let us go for the next topic. Write down. What is the next factor? So nucleophile is a very, very important factor. So there are certain conditions for a nucleophile to be acting as a nucleophile itself. Number 1, it should be less basic. What do you mean by less basic? Less tendency to attract beta proton, and it should be strong nucleophile. What do you mean by a strong nucleophile? More tendency to donate electron. அவ்வளவுதான்.
Okay.
Greater tendency to donate electron. Or example எடுத்துப்போமே. We'll take one example. We'll take it in alcohol itself. CH3OH. Okay, plus H2O gives you CH3O minus plus H2O. Correct?
Yes, sir.
H3O plus illa. And the hydrogen water வாங்கணும்னா it becomes H3O.
H3O.
So compared to this, this has 1 proton less. So we call this as the conjugate base, and we have called this as the, yeah. So this is a conjugate acid, because the one which has more hydrogen is a conjugate acid. The one with the less hydrogen is conjugate base. And then you have to compare H2O with H3O plus. So this is a conjugate base. This is a conjugate acid. Did you notice the conjugate acid base pair is formed? This is by the theory called Laurie-Bronsted concept. ஞாபகம் இருக்கா?
Last year.
Yeah. Laurie-Bronsted concept or conjugate acid base theory. So now I have the conjugate acid of the methanol and the conjugate acid of the, conjugate base of the methanol. So இவங்க ரெண்டு பேர்ல who will be a better nucleophile? So obvious, there is a name. There is a name, right? ஸோ கான்ஜுகேட் பேஸ் இருக்குது, கான்ஜுகேட் ஆசிட் இருக்குது. நம்ம இப்போ தான் கொஞ்ச நேரத்துக்கு முன்னாடி சொன்னால் இட் ஷுட் பி லெஸ் பேசிக்னு. பட் இங்கே பேஸே வந்துட்டு பெட்டர் ஸ்ட்ராங் நியூக்ளியோஃபைல். திஸ் இஸ் அ ஸ்ட்ராங் நியூக்ளியோஃபைல். Then the conjugate acid. It's a weak nucleophile. Though I said alcohol can act as nucleophile, ella unmada, I'm not denying. But when you compare to the conjugate base of the alcohol, conjugate acid of the alcohol is a weak nucleophile. Why it is like that? Very simple reason. The electrons are free here. Unlike the electrons of the oxygen in methanol, the electrons are free. So already to a proton இருக்கிற இடத்துல இன்னொரு electron வந்து அழகாக உட்காந்துருக்கு. So automatically where the electron is more available when compared to these two. So here the electron is more available. என்கிட்ட வந்து I have 20 kilograms of rice. Another person is having 40 kilogram of rice. Among the two, both have tendency to give. I am not denying both of them are not having tendency. Both have tendency. But among the two, who is better?
The 40 kg.
அவ்வளவுதான், அதே தான். இங்கே எக்ஸ்ட்ராவாக இருக்கிறதுனால he can easily give. So this is the condition for a nucleophile.
Yes, sir.
Another condition. When an electron donating group is attached, it should be attached to an electron releasing group. So methyl is an electron releasing group, and this effect is enhanced. இதுவே electron withdrawing group இருந்தா automatically the nucleophilicity will go down. So what is attached is also very very important. What is attached to the carbon or the donating group is very very important. So இங்கே மெத்தில்ன்றதுனால மெத்தில் இஸ் வெல் நோன் ஃபார் இட்ஸ் இண்டக்டிவ் எஃபெக்ட் அண்ட் ஹைப்பர் கான்ஜுகேஷன். அதனால் எலக்ட்ரான் சரன் கொடுத்துரும், ஒன்றும் பிரச்சனையே கிடையாது. பட் வாட் இஸ் த ப்ராப்ளம் வித் அன் ஆல்கஹால்? இட் ஹஸ் 2 lone pairs which are also tendency to get donated. அவனும் நல்ல லூயி ஆசிட் தான், ஐ மீன் லூயி பேஸ் தான், கொடுக்கலாம் எலக்ட்ரானை. What is a Lewis base? One who donates a pair of electron. So by conjugate acid base theory, by the stability, யார் ஸ்டேபிள் இங்கே அப்படிங்கிறத வச்சு சொல்கிறோம். Who is more stable? Methanol is more stable than its corresponding conjugate base, isn't it? So when something is more stable, it will be less reactive. Why something is more stable? Because of its less reactivity. Why something is highly unstable? Because of its more reactivity. So something is more reactive. நீயே பார்த்துக்கோங்க, there will be 2%. நீ அவனை என்ன டிஸ்டர்ப் பண்ணாலும் he will not get perturbed. இன்னொரு பர்சனை போய் டிஸ்டர்ப் பண்ணால் அவன் டக்குன்னு டிஸ்டர்ப் ஆகி உடனே டென்ஷன் ஆகும். Among the two, who is more unstable person? Immediately what will come in your mind? The person who gets tensed, isn't it?
Yes, sir.
அது மாதிரி தான். ஸோ அவன் என்ன சொல்கிறேன், he is highly reactive, that person is reacting too much. இந்த வார்த்தைலாம் போடுறீங்கல்ல ரெகுலர் லைஃப்லேயே, அதே மாதிரி தான். ஸோ அமங் மெத்தனால் அண்ட் methoxide ion, who is more reactive அப்படின்னு கேட்டால் methoxide, because it's unstable. So once when you talk about the reactivity, what comes into the discussion? Stability. So based on the stability, you can clearly say that the conjugate base of the alcohols are better nucleophiles than the conjugate acids of the alcohol. Am I making sense?
Yes, sir.
What is the second factor I said? Electronegativity. Number 2. Electronegativity of the electron should be very less. இப்போ more electronegative na weak nucleophile ஆயிடும். More electronegative na it becomes a very weak nucleophile. So for example, yes, fluorine compare பண்ணும்போது iodine and fluorine, if you compare both of them, who is a better nucleophile? Iodine, because it's bigger in size. Yeah. The electrons are more easily lost when compared to our fluorine. Fluorine la irukka electron வெளிய எடுக்கவே முடியாது, because of its small size and high electronegativity. Fluorine will not easily give away its electron.
Yes, sir.
So compared to fluorine and iodine, who is a better nucleophile? Iodine. So you can easily say that compared to fluorine, iodine is more because of high electronegativity. Fluorine is more electronegative, so it's not ready to give the electron, while iodine is bigger in size, so the electrons
Bigger
are
in size.
more easily lost. Am I making sense?
Okay. Yes, sir.
So this is about the nucleophile. இன்னும் நிறைய elaborate பண்ணலாம். I don't want to elaborate further. Shall we move forward? Have you copied?
Yes, sir.
Sometimes nucleophile can also act as a base. Though you call it as a strong nucleophile, என்ன கதை சொன்னாலும் sometimes they act as a base. எப்போனா, so whenever I say a base, it will abstract a beta proton. Alpha carbon attack பண்ணாம நேரா beta proton absorb பண்ணிடும், abstract பண்ணிடும். For example, you take this one, CH3 CH2 Br. So you just treat it with CH3 CH2O minus. Again I am going to use same CH3 CH2O minus. Sir, both are same nucleophile, sir. Yes, both are same nucleophile. But what is the controlling condition? Temperature. This is low temperature. This is at high temperature. Please make a note. High temperature will always leads to elimination reaction. Low temperature leads to nucleophilic substitution reaction. அப்போ என்ன பண்ணுண்டா, இது என்ன பண்ணும் சார் அப்படின்னா, this nucleophile will come and attack the alpha carbon from the rear side and bromine will be removed. So your product will be, இதெல்லாம் ஸ்கூலில் சொல்ல மாட்டாங்க, so please make a note. CH3 CH2 Br போயிடுச்சா வெளில, so put Br minus plus what do you have here, OCH2 CH3. So what's your product? You get a diethyl ether. அதுவே high temperature na, it will not target the alpha carbon, it will target the beta proton. Okay, I'll write it separately so that you will not get confused. So CH2, இந்த ஹைட்ரஜனை ப்ரொஜெக்ட் பண்ணி போட்டிருக்கிறதுக்குன்னா உனக்கு புரியணும். So it will abstract the proton. So this is called as beta elimination. So what will happen? Minus H plus, not minus H plus avella pohadu, it is going out as ethanol, minus ethanol, minus Br minus. So what will you get as a final product? CH2 double bond CH2. You'll get alkene.
Yes, sir. CH2.
So temperature is a very very important factor. Nucleophile evlo important oh adukku equal temperature equal factor.
Yes, sir.
So both of them are alkoxides only. இதுவும் alkoxide தான், அதுவும் alkoxide தான். இப்போ தான் படிச்சோம், alkoxides are very good base and acid. Very good base and a nucleophile. எப்போ it will be a very good nucleophile? At low temperature. அதுவே if you apply high temperature, it will act as a base.
Yes.
So this is a very 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 important factor.
Yes, sir.
Right. So this is one of the properties of the nucleophile. Idhula we have another set of nucleophiles called ambident nucleophile. Enna peru?
Ambident nucleophile. They have two nucleophilic centers.
Correct. Oh, இது எப்படி புரிஞ்சுக்கணும்னா, there are two nucleophilic center but only one will attack at that particular time. For example, you take RX and you treat it with potassium cyanide in presence of ethanol. Compared to potassium cyanide, we are also going to treat it with another potential cyanoid called as silver cyanide or AgCl in presence of ethanol. Now what will happen? In both the case, X minus will be removed. Okay, in this case it will come out as KCN, KX. இந்த இடத்துல it will precipitate as AgX. இந்த கதெல்லாம் நமக்கு தெரியும். What will happen to the cyanide? Which phase will attack? அப்படின்னா compared to KCN, AgCN is less polar. அப்படின்னா என்ன அர்த்தம்? What do you mean by less polar? This is covalent. This is ionic. What do you mean by ionic? K plus plus Cn minus வெளியே வரும். இது அப்படி இல்லை. AgCNன்றது bond வந்துட்டு it is covalent. அதனால bond உடைக்க முடியாது. So since the C minus is available, automatically the cyanide is formed. So we call this as the alkyl cyanide. இப்போ which is available in AgCN? The nitrogen is available. So the N will come and attack. So we call this as alkyl isocyanide. இதே மாதிரி தான் if you take another set of nucleophile, for instance AgNO2 KNO2. So here I am having the same R, no change. If I add AgNO2, my product would be RNO2. I'll get nitro alkane. Other way, if I treat it with KNO2, my product will be ONO. That is alkyl nitride. So இந்த மாதிரி இருக்கக்கூடிய reagents, இந்த மாதிரி இருக்கக்கூடிய nucleophile பேர் ambident nucleophile. They have two bonding site, but they will bond with only one at a time, depending on the condition.
Yes.
So any doubts, ma?
Sir.
Is everything clear? So now you know what should be acting as a better nucleophile and all those things. I think now you are very clear. So it should be a better nucleophile na. It should have the capacity to donate electron. It should not abstract proton. In the mari we have many other conditions for nucleophile, and it should be less electronegative. It should not be more electronegative. So again, along the period போகும்போது the electronegativity increases. So when you see elements along the period, they will be weak nucleophiles. But when you come down the group, the electronegativity decreases, so they are strong nucleophiles. For example, when you take ammonia, இப்போ அம்மோனியாவையும் phosphine-ஐயும் compare பண்ண, you have ammonia and you have phosphine. Both of them are having electron, both of them have the lone pair of electron to donate. But compared to ammonia, phosphine is a better nucleophile. Why? Here the electrons are localized. It is in the same place. Here the electrons are delocalized. So the electrons are moving. So compared to ammonia, phosphine will be a better nucleophile, because the electrons are delocalized, and the electronegativity of compared to ammonia, phosphorus is less. So same concept, different questions they might ask. This 1 mark la keppa. 1 mark la kekkumbodhu, among the following ions, which is a better nucleophile அப்படினா நீ வந்து electronegativity வச்சு டிஸ்கஸ் பண்ணி சொல்லு.
Yes.
So am I making sense? Nucleophile na
Yes.
What all you now you understood. So we are done with substrate, we are done with nucleophile. Okay. Now shall we go for the next factor? What is the next factor? Leaving group.
Leaving group.
Leaving group la we have only alkyl halide. Iodide is a better leaving group than bromide. Bromide is a better leaving group than chloride. Fluorine is the very bad leaving group. It will never leave very easily because the bond is very strong. So the CF bond is very strong, so it will not leave so easily.
Yes, sir.
So leaving group, this is the trend they follow. Iodine is a better leaving group than bromide. Bromide is a better leaving group than chloride. Chloride is a better leaving group than fluoride. So the last factor is the solvent. See, remember in SN1 mechanism, you will find some ions formed. In SN2 mechanism, there is no ions. In English, they will use a word called no strings attached. I don't have any relationship. There is a word called no strings attached. So, what is this string that is attached? The charge. So, charge is the important factor. So, in SN1 ions are generated. So, you need more polar solvent. Since there is no ions, you require less polar solvent. On a polarity illama, you cannot dissolve alloalkanes because alloalkanes are polar. We already learnt it.
Yes, sir.
Because to dissolve some polar component, you require another polar solvent. Like dissolves like. Like dissolves like automatically it should be polar. But since there is no ions, it should not be too polar. It should be less polar. That is how the condition is. I cannot help it out. Because chemistry is an observational science. Unlike biology, physics na ஒரு law போட்டுட்டு அந்த lawலயே உட்கார்ந்து பேசலாம். Computer science na logics தான். இதுவே biology na it should crawl and creep. அப்பதான் அது பேச முடியும். Maths na பிரச்சனையே இல்ல. Imagine a parabola ன்ட்டு போய்டலாம். But chemistry is purely observational science. What you observe, based on it only you have to give your interpretation. என்ன சார் லாஸ்ட் டைம் அப்படி சொன்னீங்க, இந்த வாட்டி இப்படி சொல்கிறீங்க. இப்போ தான் கொஞ்ச நேரத்துக்கு முன்னாடி I said alkoxides are good base. But temperature மாத்திரம் the condition is changing. அதுதான். So chemistry is purely observational science. Based on the observations, based on what is being obtained, அதை வச்சு தான் உனக்கு ப்ராடக்டை டிசைட் பண்ண முடியும். மாற்றி மாற்றி பேசுகிறீங்களேன்னா subject is like that. So it's purely observational science. Okay. So now how do you increase the polarity of a solvent who's already polar? Very simple. You use a polar protic solvent who can produce more ions. Another one is polar aprotic solvent. Aprotic na you will not produce any protons. So we have something called dimethyl formamide. Adhe mari we have something called dimethyl sulfoxide. இதுக்கு ஷார்ட்கட் பேர் DMF, இதுக்கு பேர் DMSO. அதே மாதிரி சம்திங் கால் டெட்ராஹைட்ரோஃபியூரான் THF. இவங்கெல்லாம் வந்து நான் போலார், ஐ மீன் ஏப்ரோட்டிக். இதுலேயே வந்து போலார் ப்ரோட்டிக்னா THFன்னு சொல்ல போனால் இட்ஸ் நாட் ஈவன் போலார், லெஸ் போலார் தான், பட் we can consider. பட் போலார் ப்ரோட்டிக்னா you have ethanol, you have water. THF விட பெட்டர் வந்து அசிட்டோன். அசிட்டோன் இஸ் ஆல்சோ polar but not so polar. So இவங்கெல்லாம் வந்து polar aprotic, polar protic.